Glacier Lake Missoula and the Ice Age Floods, February the 21st, 2007. Missoula Public Library. 15,000 years ago, a series of cataclysmic floods roared across northern Idaho, central Washington, and down the Columbia River to the Pacific Ocean. Many land features in the Pacific Northwest have been attributed to these floods, which were due to repeated failures on the ice dam that created Glacier Lake Missoula. Glacier Lake Missoula and the floods have a strong influence on the environment and the patterns of human use of western Montana valleys.
I'm a geologist. I was educated in Southern California. I moved here into Montana in 1982, worked over in Billings for about 10 years. I moved to Missoula and spent the time since 92 in this area here. Before I got here, I'd heard a little bit about Glacier Lake Missoula and something about Ice Age floods. I'd made a couple trips across Washington, over to Seattle, and see a few signs, but not a lot of stuff. Talked about a flood, and I thought, okay, fine. And didn't think too much about it. Got here in 92, and I was sitting there fat, dumb, and happy down at the office that following winter in 93. And one of the guys that I work with over in the regional office phoned up and says, well, there's a couple people from the Park Service going to be coming down over here and giving us a talk about Glacier Lake Missoula and Ice Age floods. And what their intent was to get a bunch of people from the federal agencies, state agencies, and even from the private sector interested in the Glacier Lake Missoula story to facilitate the telling of that story. So I went down there and heard this story, and I have to tell you, I was awed when it got done. And I just said to myself, this is something I need to get involved with. Part of the reason for that was back in my college days, and when I was first started off as a professional career, I taught high school for about 5 years, and I worked during the summer for the Park Service. So it was natural for me to kind of get into interpretation, and I kind of wanted to follow that venue just a little bit further, and here was an opportunity to do it. But the further I got into it, the further I got sucked into the story and the whole tale and everything. And it's really a fascinating thing. And I think, but going back to the story in 93, we met over in Spokane for a couple of years. And by and large, I'd say that we had a lot of people in the initial stages of the whole thing. We'd have 80 or 90 people from the 4-state region, which include Washington, Oregon, Idaho, and Montana. Very few people from Montana at that time. And they'd get together in Spokane every so often, and we'd talk about things. Well, as time went on, we didn't produce very much. Because really what the intent was of the Park Service was to get some federal legislation enacted. Well, that's kind of like watching glaciers move in a lot of cases. It's very slow. And the people who were in the business sectors, the Chamber of Commerce, kind of lost interest, and they went off to do other things, and I could understand that. We lumped along for a couple of years, and then in 1994, at the suggestion of somebody we were working with, said, well, you need to form a citizen group. And this is the history of most park formations. Having worked for the Park Service, I know that. Prior to a park being designated by Congress, usually there's a citizens group that speaks to that issue. And they go before Congress. Now, one thing you have to know about being a federal employee, you cannot lobby Congress. In 1999 and into 2000, the Park Service wanted to do a study. And one of our early on goals was to put together a glossy little brochure that we could give to the Congress and outline our plans, our desires, and all this other thing. In 2000, we got $200,000 to put together the report, and it was put together. And what they had done initially was, in using the people from the Ice Age Floods Institute and other citizen groups, plus some of the people from the state, they formulated 4 areas to take a look at. We had the Glacier Lake Missoula area, we had the Idaho Panel and East Central Washington over in here. Then we had the Mid-Columbia, and then, of course, the Gorge and Lower Columbia down to the Willamette Valley. We all then compiled a bunch of information, places to go see, public interests, and all these other things that went together. And in 2001, the report came out, and this report, I think you have a study of it here in the library somewhere. You can pick it up and look at it. It's assessment. Well, it came out in early part of 2001 and had to go through the Secretary of Interior for approval before they would pass it on, the Secretary would, to the Congress for consideration. As fate would have it, that report hit Congress the first week of September. A couple days later, we had some problems in New York and elsewhere. And this thing just took back seat for a long time, understandably. But things have moved along since then, and we'll get to that in a moment. But one of the things that the report did do, it identified within some of these subregions things to do in the sea. We also laid out some proposed trip loops and things like that where people could get a guidebook or whatever else and put it together. One of the problems that's been facing this whole telling of the story is there's no comprehensive, coordinated way that it's been approached up to this point in time. That's not quite true now, but it was up until maybe the late 90s. And so this was an attempt to get all areas in sync, telling the same story with the same kind of a poster, like Lewis and Clark pointing and this whole thing. So that's one of our big goals. So we identified several of the trails or routes that you might want to follow. We like to call them pathways because the floods followed pathways. And one of the gateway cities happens to be Missoula. And as you can guess, Glacier Lake Missoula extended here, as we will talk a little bit to the east of us, about 45 miles out to Garrison Junction. So if you're on the I-90 corridor coming from New Jersey, your first contact with the lake story will primarily be here in Missoula. And as all of you know, you look around the hillsides and you see ample evidence of the lake having been in this location in the past. So anyway, that'll be one of the gateway communities, and one of the things that we really want to see here is a visitor center dedicated to that, maybe in partnership with some other people. Now, the Ice Age Floods Institute, since its inception, has been doing a number of things. We offer field trips occasionally. We had one here in the local chapter. Each chapter has to offer one every year. We have 8 chapters now between the 4 states. And the Glacier Lake Missoula chapter is located, of course, right here in Missoula itself. And we offered one that went up into the Flathead country. Kind of an interesting trip last fall. Were there anybody here in the room on that trip? I don't see anybody. You might want to look for them next year, that we'll have one somewhere in the area. The other thing we've done, we've been involved in the creation of several videos. And this one here, I know the library has. This one I don't think you have. That's the public station from Portland, Oregon. And unfortunately, you don't have this one, which I think is one of the better ones. That was done by KSPS over in Spokane. And so one of our missions in the Ice Age Floods Institute is education. And to meet that goal tonight, we're going to dedicate this to the public library. Got you a copy of it here, and you'll have it now to check it out. It's an hour-long program, and it was done by Allison Cordovalt. She's done a lot of good stuff for KSPS and other places. She's unfortunately moved out of the country right now. We've also had some input into some of the magazines, one of them being Horizon Air a number of years ago. So as you flew over from Missoula over there, you look down at Washington, and you get an idea of the story and talks about it. One of the other things we're doing is selling Glacier Lake Missoula. Now, we can look at that in several ways. One of the things that we always wanted to achieve is bringing in more tourists into the countryside. Because you're not going to get people to get on board, the Chamber of Commerce's and other people, the city mothers and fathers, unless there's going to be a buck involved. It's just that basic. I hate to say it, but it's true. And so one of our mantras was from the beginning was one more day. We want to keep people in the community one more day. And my vision is to have a nice center, preferably down around where the ballpark is, where we can co-op with the parking area down there. Can you imagine coming into Missoula, wanting to go into the downtown area, and you have a 25-foot trailer behind your car? You know, you can't even find a place to park for a small car, let alone a unit like that. But how much better would it be if they got off Orange Street or off Van Buren, came down here, and were directed over to the ballpark area, got to park there. The trolley comes through and picks them up. And also they can walk across the street into the visitor center, see the story. And by the time they're done with all that, it's 4 o'clock. We best find a place to stay for the night. And so that's the types of things we're selling, not only here in Missoula, but all the way across the floods area. It is a big incremental increase in visitation and tourism, but it's nonetheless some that we need all here in the Pacific Northwest. One of the other things I might mention before I leave this, what we have now, we had 2 bills introduced in the last Congress. We got them both passed, but unfortunately they didn't get reconciled, so they went down. Our 2 new bills, which were introduced here last month, are Senate Bill 268, put out by Maria Cantwell over in Washington, and House Bill H.R. 450, which was also a Washington representative that put that one in, Doc Hastings. The Senate bill cleared the subcommittee the other day and will probably go for vote after the recess is over. There's current recess in Congress right now. And the strange thing of all this was, and I had a visit with a representative's staffer and a senatorial staffer this afternoon or morning, and there are no congressmen, there was no congressman and no the 2 senators co-signers on those bills. The other states have co-signers on the 2 bills. The representatives are on their bill from the 4 states and from 3 other states, I should say, and from the other 3 states, there's senators on the Senate bill. I would ask you to encourage your senators and your congressmen to become co-authors or co-signers on this bill so that when it goes up before the bodies for election on the floor, it gets passed. I will tell you this, the previous bill, Senate Bill 206, was voted on unanimously. I mean, how often do you see a Senate or a House bill that goes in unanimous vote? Cleared. And I would hope the same fate awaits these 2 bills too. Today's travelers, if you're traveling through the Pacific Northwest, can look at the evidence to a mystery that really confounded geologists for decades. One thing that the geologists like to pride themselves on is that we're kind of forensic scientists. And looking at a lot of the evidence that they saw at that time, such as these large, enormous, and somewhat empty canyons in central Washington, and these rim-like features that look like waterfalls with deep plunged pools at their base, and these house-sized boulders that appear to be cobbles, broken loose and tumbled by a stream in a river-type system, and large ripple marks. Now these are all seemingly water-created features, but all of the size and scale seen nowhere else on Earth. In that part of east central Washington known as the Channel Scablands, a long way from any large bodies of water that could seemingly have created them. That is until a gentleman by the name of J. Harlan Bretz came along in about 1923 and proposed a very fantastic and outlandish reason for their existence. One that just didn't fit well at the time and met with a lot of scorn and controversy. And that was a flood of cataclysmic proportions, greater than any other ever documented in the geologic record. Now, the same area had seen floods before, but of a different form. Back around 17 million to about 5 million years ago, there was floods of molten rock material or lava that broke out and poured out across the country, forming layer by layer, very slowly, the Columbia River lava plateau, or basalt plateau as we like to call it. The basalt in the Columbia Plateau area, which is out towards Richland and north of there up towards Grand Coulee, is over 10,000 feet thick in places. As that lava started to cool, it started to shrink and crack, and in some areas form vertical columns of basalt. Now, about 3 million years ago, the volcanic fires were replaced by the deep freeze of the Ice Age. And large glaciers started to form in the northern parts of the hemisphere and also in the mountain regions. And about 15 to 17,000 years ago, one figure of the Cordilleran ice sheet came down the Purcell Trench and plug the Clark Fork River Valley with a big ice dam right here as you get into the Sandpoint area. That ice dam was approximately half a mile high. And as the water started to back up behind this ice dam, it started to flood many of the western Montana's valleys. And as it did so, it created Glacier Lake Missoula. Anyway, Glacier Lake Missoula extended for hundreds of miles in all directions. The ice dam is up here. You come down Trout Creek would be in here, Plains, and here's Camas Hot Springs. Calisto would be up here, of course Missoula, Drummond, and all the way down to Darby. So you could have, if you had a boat, you could have gone all the way to Darby on a boat. Now that was at the biggest and the deepest of the lake, which then was about 2,000 feet deep down here at the dam area. That would be probably the deepest lake in North America today. And does anybody know what the deepest lake in the United States anyway is today? Crater Lake. Now even as far east as we are here in Missoula, the lake was nearly 1,000 feet deep. So as you look up at the M above the university, that was underwater. But you know, that's about 860 feet up, I think, or something like that. So it was above that. Now, well, if you've ever taken ice and you put it in a drink, probably pop, never alcohol or anything like that, you know that it floats. But the water has to be at least 9/10 the height of the ice to make it float. So as the water's backed up behind this dam that was 2.5 or a half mile high, about 2,500 feet, got to about 2,000 feet, it started to lift up that ice and started to work below it until it gets out to the edge. And in so doing, it kind of makes cavities inside. And that surface then started to break up and cave and collapse. And at one point then, the whole thing collapsed in on itself and blew out the mouth of the Clark Fork River at a force of volume 10 times, now get this, 10 times the combined flow of all the rivers in the world today. You think about that. 10 times the flow of all the rivers in the world today. I mean, the Amazon, the Nile, they're big rivers. Mekong, Mississippi, 10 times that and every other river that we know of. Now, back in 1910, Joseph T. Bardee, who was a geologist for the U.S. Geological Survey, was one of the first people to write about Glacier Lake Missoula. And he put together a paper that was in the Journal of Geology. He recognized the existence of Glacier Lake Missoula. Looking at this problem here, when he found out about the floods, he says, you know, water coming through this sluiceway here that exists between Plains over here and Thompson Falls down here, and approaching Eddy Narrows, which is just a little bit upstream from Thompson Falls, this area right here, just before you come into Thompson Falls. It's about 3/10 to 5/10 of a mile across from the highway over here to the other thing. The water coming through that gap at the height of the biggest flows would be moving at 9.4 cubic miles of water per hour. Now I should go back and tell you, I got kind of distracted back here. The volume in the lake at the highest stand of the lake was approximately 500 cubic miles of water, which is kind of like Ontario and Erie being combined today. If you take that 9.4 and divide it in there, theoretically the lake could drain in as little as 2 days. But there's other constrictions and stuff down the line that prevent that from really happening. So probably the drainage factor from a high standard lake was probably somewhere between 2 days and 2 weeks or so. As that water ripped out and went across the landscape, all the way down through central Washington, down through the Columbia River Gorge area, and down into the Willamette Valley and out, it carved away at approximately 50 cubic miles of dirt and earth. A lot of that dirt and earth, as we shall see, ended up in the Willamette Valley. They can thank Montana, Washington for their fine soils in the Willamette Valley, from which the pioneers went for in the 1840s. And a lot of that sediment also went out into the Pacific Ocean, and you find it offshore California now as well. In the Palouse country of eastern Washington, up to 200 feet of topsoil was quickly stripped away, gone. leaving behind only the scabby basalt lavas beneath it, hence the term scablands. In areas where the water could roar through there and easily pick the basalt apart column by column, it created these deep little canyons. And in other areas, it was able to pluck out large boulders 30 feet in diameter and tumble along the bottom of the moving water column. Sometimes these went a half a mile or more. As you can imagine, though, as they got tumbled and tumbled, they broke up and then they became small little pieces. These canyon bottoms in here and all the way up to the top are filled with water until it overflowed, and in areas cutting these intertwining complexes of canyon systems. Now, in the central Washington area, you don't see the normal dendritic or tree-like branching style of stream beds that you would normally associate with the western United States, but you see this chaotic braided stream bedding system. It's only when you move back out into space do you see it in its total format. What you were just seeing was one of these areas about this big, just in the previous photograph. This is the whole area from Spokane all the way across to Wenatchee. At one time or another, all these lands in here were involved with the flood history and the flood process. Now, the greatest flow of water was down the Grand Coulee. And here at the side of the Grand Coulee Dam, back in one of the parts of the Ice Age, another figure of that ice from the Cordilleran ice sheet came down. This would be the Columbia River drainage right in here, block that drainage, force the water along the edge down this direction here about 20 miles to form a large waterfall 900 feet high. As the water piled over this waterfall, it started to eat behind it and cave back, and this thing would drop back, and you'd have what's known as a recessional waterfall gorge. This one here, the Grand Coulee, is 20 miles long, 1 to 6 miles wide, and over 900 feet high in its deepest places. It's probably also one of the more beautiful waterfall gorges. Now, I might mention that the water in the Grand Coulee, as you see it today, and elsewhere in that region, was not there until the reclamation activities commenced back in the 40s and 50s in Washington, primarily to get water for agricultural purposes. But the biggest waterfall of them all was on the lower Grand Coulee. And this is it right here, 3.5 miles across. This is an area known now as Dry Falls. If you've been out in that country, this is the Dry Falls Visitor State Park. It's ran by the state of Washington. And the water came down here, all the way here, actually off the photograph even, and poured over this thing that we now recognize as Dry Falls. An equal, same scale rendition of Niagara Falls would just occupy that amount of area. Dry Falls took all this in down here, 3.5 miles across, and a lot higher in rock distance as well. So it'd be kind of a paltry little affair. Don't tell people in New York, but anyway. Here we see the Dry Falls area. This is from the visitor center area, and you can see these where you can see actual water. It looks like there was a waterfall coming here, and here are the edges of the stream bed. This was all over water at one time, probably, because the water that was coming this way towards you was probably 300 feet deep and roaring along at about 50 miles an hour. And I imagine in the bigger floods, probably went through there with not so much as a blip in the surface. It'd be one heck of a good raft ride, you know, but it would be kind of dangerous. Now, one of the things that was really one of the problems that Brett's had in trying to convince people about this story was that you have to think in terms of a big river. I mean, really big river. Remember we were talking about 10 times combined flow? So you have to take your mind and you have to scale it up to try to understand what you're seeing. And everything else behaves the same way as a modern river, or one of the smaller rivers you might say, but it's just on a bigger scale. And in these areas where you have obstructions, water slows down and starts dropping out sediment, and it forms gravel bars, point bars. And this one in here is known as the Moses Coulee one. It's 3 miles long, and it's as high as a 30-story building. This car here is going over this gravel bar right here for scale, so you can get a little bit of an idea of what it looks like. As the water slows down, it drops its sediment load, sand and silt. This stuff can hardly be called sediment, but that's what it was carrying along the bottom of the river, or in this case, the flood areas. In other areas, you'll find these large, humongous boulders, 200 tons or more in size. Now, those probably were not carried along by the water, but rather they were entrained in some of the icebergs that were glaciers. They've been brought down from the Canadian Rockies. Also, some from Montana have been found all the way into the Eugene area and the Willamette Valley area. So it carried it quite a ways. So these bigger boulders are found in these various areas from British Columbia and Montana. We were on a field trip here about 3 years ago, and we found one very unusual rock up in the Camas Prairie outside of Hot Springs. I've never seen anything like it in Montana. And I'd like to get back up to Canada and look around, because it's just a big car-sized boulder. It's purple in color, and I've never seen anything like that in either the park, the Glacier Park, or up in any of the areas I've been in northern Montana. We have another type of feature here in the western Montana area. They're called gulch fills, and you can see one of them up in here. You find these down along the Clark Fork River between St. Regis and Paradise, and also along the Flathead River around Perma. Now, these are areas where, well, if you were to take today your large boulders and you have spring runoff and you have a lot of water moving down the Clark Fork, the Bitterroot River, and you were to go there right after the high mark of the spring runoff were completed, you would see little sand and silt, pebbles and stuff that were entrained between the boulders, you know, and it filled it up a little bit. And that's what this material is. These are the big boulders and the things. These are hillsides, of course, mountains. And this is the material. This is the size of the material that came down there, and it's the same thing as sand and silt grains in the rivers today. Water was moving through there, maybe 500 to 1,000 feet deep or more, at a speed of 50 or 60 miles an hour. It had a tremendous amount of power to move materials. All that water then had to find a way out, and it came to a screeching halt down in Wallula Gap. This is a location down in the Tri-Cities area, right down here. Richland is up in here, and Kennewick is here, Pasco is right in there. And this is Wallula Gap. It has to go through there and install the waters, forming the lake about 1,000 feet deep. It also sent the waters surging back up the Snake River 100 miles towards Lewiston, Idaho. At the height of the biggest floods, probably these hills were overtopped with floodwaters. And it formed a vast lake in here, flooding that whole area around Yakima, Pasco, and so forth, with a large series of lakes that took days to drain. And when those lakes drained away, the water saturated hillsides in the region. A lot of them collapsed because they were just lubricated so that they could just move right down. The water then is tore on down through the Columbia River Gorge, probably 1,000 feet above the present level of the river, scraping stuff off, cleaning things off as it went, widening it maybe a little bit. Not a lot of evidence for that, but surely I had to clean away the rock ball material that came down. Went over the top of this structure, which is known as Crown Point, about 560 feet above the level of the river. Just downriver from Crown Point, you go through the town of Troutdale, and the river really restricts itself down there. We'll get back to that in just a moment here. But in the areas where it did clean off the things, we see the real nice waterfall systems in the gorge area, make it really a scenic drive for anybody. Down here is where Troutdale sits, and there was a sharp bend in the Columbia River at that point, or still is, and that forms what we call a hydraulic dam. And it's kind of like, I like to explain it this way. You go to a Grizz game, and everybody's in there cheering for the winning team, us, and then the game's over and everybody wants to go home, right? But you only have so many gates open. And everybody runs for those gates and the whole thing slows down for a bit until you get through the gate. That's the same thing that happens in a hydraulic dam. You go through these constrictions, the water slows down behind it. But you also build head. And the head, after this and all this water upstream, the water coming out of the Columbia River gorge in this area was coming out at a force of 90 miles an hour. And there are places down there in Troutdale and just in the communities to the west of that where you find these large boulders that were just swept right around and in behind them. And also you find them over in the university system too. Because as it came out of Hellgate Canyon, it picked a lot of them up. And when they were building some of the new additions on the gym and a couple other places, they really ran into some big rocks. And there are houses over there that have rocks in their basement that aren't going to go anywhere because they're too big. And that's part of the stuff that's come out of Hellgate. Well, let's go back and do about one thing here. The water again went all the way down to almost Eugene. Fill this whole area up in here. We find remains of mammoths that were drowned. They're probably happily out there eating something in the plain that was the Willamette Valley at that time. Got drowned and buried. But anyway, the water in here built up to a depth of over 400 feet. Some of these taller skyscrapers here in Portland, the buildings may be the only ones that would have stuck up above the water level if the flood were to come through today. Now, sea level was lower during the ice ages than it is today. In the last ice age, approximately probably 300 to 350 feet. The current shoreline for the Pacific coastal margins of Oregon and Washington would be right there. All this land out here would have been exposed at the time of the ice ages when you had maximum water out of the ocean as the form of ice on the land. Now out here on the coastal plain, or underneath now, on sonar you see evidence of a gorge or a canyon 300 feet deep that was cut in part by these floodwaters that came out due to Glacier Lake Missoula when it came out. Again, the sediment coming out was picked up by the longshore current drift and moved down to California, a lot of it. So at last, all the waters of Glacier Lake Missoula, all 500 cubic miles of it, finally got out to the ocean area. But one of the things that happens, once this thing blows out, that ice up there just north of Sand Point is not going to stop. It's going to keep moving south. And so that gate, or that barrier, is going to slam against those mountains very quickly and form another ice dam. And therefore, we know that there was many other Glacier Lake Missoulas coming back. Some people estimate as many as 40, others as many as almost 80 to 100 over the period of time in the last glaciation. A period of time between about 17,000 and about 12,000 years ago. We see the evidence for this in the lake flood sediments here. These are down by Walla Walla. That's about 180 feet from there to there. All the sediment in here. One of the best places in western Montana to see it, and I'd ask you not to stop on the highway to take the cutoff up to the ranger station, is right along the interstate there at 9 Mile turnoff. And you'll see this nice pink stuff. This is mostly lake bottom sediments. And I will tell you one thing, you do not want to go there when it's wet. You'll have it everywhere, in the car, and whatever you're driving on your shoes, it never comes off. I don't think sometimes. But it's a very clayey material that was on the bottom of the lake. But despite all this evidence for floods and everything, people just didn't believe the story. And because there was one piece of crucial evidence that was never examined real closely, never put into its perspective, and we'll take you back to those series of rather unassuming rolling hills, those ripple marks up in the Camas Prairie, which is north of Perma and up towards Hot Springs. To do that, we'll go back a little bit in history. At the turn of the last century, the geologists came into the countryside to do some of the first reconnaissance mapping. They came by horse and by car. And one of those first geologists was J. Harlan Bretz. He was born in Saranac, Michigan in 1882, was educated at Albion College in Michigan, and upon graduation in 1906, he took up a job as a high school biology teacher in Seattle, Washington. And I think this was the start of his fascination and his career with the topic of Washington and the Ice Age floods. Anyway, he quit teaching in 1910 and decided to go back for a graduate degree and went to the University of Chicago. And his master's thesis was on the glaciation of the Puget Sound area. And he graduated about 1913 and started working as a college professor of all places in the same institution, University of Chicago. And about 1922, he became very fascinated with the Channel Scablands areas of central Washington, and took a look at this and wondered why, and looking at the topographic maps that were coming out at the time, why some of these features were the way they were. He then made up, or I should say, decided that the reason for this was a large series of Ice Age floods. Well, you have to understand the context of the time. This is during the Scopes trial period. And his colleagues in the geological profession were very afraid that they were going to get dragged into this whole thing. And so they really frowned upon his ideas of catastrophic floods and all this other stuff. And they kind of put him down. For one reason, it would be kind of running counter to one of their core principles put forth by James Hutton a number of centuries before, that of uniformitarianism, the present is the key to the past. And nobody had seen any large floods like this, you know. They don't occur, do they? Well, they do, but not in the part of the world that most people were looking. Some of the Alaska coast down in Patagonia, but those hadn't really been visited by geologists up to that point in time. So they didn't like his idea of catastrophic occurrences and things like that, and so they set up to do him in. In 1927, they set a trap and they invited him to address the Geological Society of Washington, and he came in and delivered a paper on Ice Age floods, or the origins of the scablands of central Washington. And they just went after him like a pack of dogs. They didn't like it, and that scathing criticism was to accompany him for the next 40 years. One of the interesting side notes to that whole thing was, one of his high school students that he had back in Seattle in that period that he taught from 1906 to 1910 was one of his biggest critics. And I met James Galooly many years later, back in the 60s when I was a college student, and he's a fiery little Irishman, and you could see it in him every time he taught. He was a good geologist, but he didn't like Bretz. Long history there. Anyway, one of the biggest problems that Bretz had to meet his criticism that was directed at him, he couldn't explain the origins adequately of the waters that would have caused this erosion to cut these channels and these rock features and everything that he said were caused by large floods. Well, sitting back in the audience was J.T. Pardee. And remember, he was the one that I told you about earlier that wrote one of the first papers about Glacier Lake Missoula. And Joseph turned to his friend, Kirk Bryan, and said, I know where those waters came from. Because he knew about Glacier Lake Missoula. Now, Joseph T. Pardee was born in Salt Lake City in 1871. And shortly after he was born, his family moved to Phillipsburg, Montana, where, while they were residing there, his father was one of the mining engineers that helped develop many of the mines in western Montana and elsewhere in the west here. Joseph T. Pardee had a long connection to Montana, and his wife here died about 7 years ago, and they left one of the biggest grants or awards to the Geological Survey for the Geological Society of America. And now they have the Pardee Symposium every year and all their meetings and stuff. So we have a lot of connections here in western Montana to what goes on in the geological world. Anyway, Joseph T. Pardee began college at Presbyterian College in Deer Lodge. And a lot of people probably don't know there was a college there for many years. Presbyterian had it. Now it's part of the grade school system over there. Now, Joseph T. Pardee didn't say anything in this meeting, and you might ask why he didn't stand up and defend the ideas of Brett's. Well, one of the people that was in the audience was William C. Alden, and happened to be Pardee's boss. Now, this is the 1927. You did not have protection in employment in those days that you do today. And he knew that if he said something, probably his job was in jeopardy. So he sat back quietly. And it was interesting that Pardee and Alden had worked a lot on glacial geology in western Montana and other places such as northern Idaho, and then on the big flats up there in northern Washington. But it didn't matter. In one instance, I do know that Pardee passed in a letter to Bretz his thoughts on the origins of the water, and Bretz just brushed it off. Bretz was kind of a very brass person, didn't really care what other people thought about him, and he said that his detractors, the people didn't believe him, that was their problem, not his, except for the fact that it took 40 years to resolve the issue. I heard from his sister one time that one of his old sayings was that one of his best enjoyments, he lived to be 96 years old, and one of his biggest enjoyments was going to the funerals of his critics. I mean, that's really taking it to the mathematics. I mean, I just sit there like, whoa. Well, what happened was that the battle went on through the 30s. Not too much was resolved in that time, but in 1940, Joseph T. Pardee went to a conference in Seattle, Washington, and delivered a paper entitled Unusual Currents in Glacier Lake Missoula. He then, a year or two later, published it in 1942 in the Geological Society of America's Bulletin. But he, being a quiet man, he just didn't raise a lot of interest. And the other problem that we were facing at that time is the fact that this was the war years. And academic squabbles just were not of a concern at that point in time. They just kind of went off the board. And so the whole issue kind of, simmered for the next couple years until which time the war was over. And after we got into the late 1940s, the whole question came back up and we started talking about it. Well, about early 50s, I would say, mid to early 50s, they had a series of field trips, and they came out here, and these rather unassuming ridges that we see in the Camas Prairie area were linked to a solution here. Now, looking from 5,000 feet up, which was the advantage that we have today, but they didn't have back in the 20s so much, was aerial photographs. What was visible was as easy as taking a walk on a beach. They were ripple marks. But in this case, giant ripple marks, 30 feet high, 2.5 miles long. Now, what does it take to form ripple marks? What type of water? Moving water, right? Fast moving water. And James Galooly sat there in that field trip and looked out and said, God, I was wrong. I don't think he ever told Bretz that, but he was wrong. Because this was the key right there when they looked at that. Because there's another side to that. When you take a look at a general map, Camas Prairie sits right about in here. And what's the drainage that serves it? Clark Fork River, right? Goes down and up into here, around the corner, and then joins what is this? This is the Columbia. And then down through Lula Gap here, it goes over here, and out to the Pacific. Well, if you take the water here, then it takes it across central Washington, does it not? And then right there, if you were a critic of Brett's, you were had. If you believed in Joseph T. Pardee's ripple marks, then you had to believe in Brett's floods. And that was the telling truth right there. But it was interesting because this was in the early to mid 50s, and when I was an undergraduate, about mid 60s, Some of the textbooks still refer to this as a theory. Since the 1970 on, it doesn't, but up until that point in time. So it went from essentially 1927 to about 1967 before it was generally accepted by the geosciences, that community. Once these ripple marks in the Camas Prairie were recognized, we begin to see them all the way down the flood channels, all the way out to the Pacific Ocean practically. You see them in various other places. One of the other things that we noticed too, a lot of the flood channels are convenient places to route cars and stuff. So a lot of our highways go down through the flood channels as you go down through the central Washington regions. Those soils that were carried off and deposited elsewhere, some of the best farmland in Washington and Oregon is made up of that, that soil that was ripped up by the floods. One of the biggest things going on right now down in the Walla Walla area and just north of the Tri-Cities areas are wine tours that feature Glacier Lake Missoula flood deposits. And that's what they get all the geologists in. Of course, we're friends of booze anyhow, but I mean, besides that, it's a drawing card, and they go in and see the stuff, and they go in here, and a lot of the wineries now are really, their premier grapes are coming off the flood materials. And a lot of the sculpted out areas are some of the best recreation areas forming lake basins. And of course, we have the waterfalls that we owe to a lot of the floods. This is Palouse Falls, just out of Walla Walla, north of there a little bit. And also the flood deposit gravels form some real good aquifers. We are the benefactors of one of those aquifers right here in Missoula. So is Spokane, where this photograph was taken. Vast underground storage areas of loose rock and gravel materials. So J. Harlan Bretz was right, but he left us a lot larger legacy, I think, in being so steadfast and resisting backing down from those principles which he felt scientifically were well founded in what he had done earlier. And it's a good thing he does, because when we take a look out into our modern world here, we are more appreciative, I think, of catastrophic events and the effects on our day-to-day lives and effects on the landscape. When we look out into the cosmos, we see such things as asteroids coming in and hitting Jupiter a couple of years ago. And then a lot of people, of course, attribute the demise of the dinosaurs 65 million years ago, a good portion of it anyhow, to a meteor or asteroid hitting the world and putting them out of business. As we go off into space and we take a look at places like Mars, we see a lot of features here on the Martian surface that resemble things we see in the scabland. Drainage patterns and such. It's remarkable how much there is. Take a look at this, and this area in here. I'm just amazed at how familiar they are in form and everything else. And one of the things that the NASA scientists wanted to do was they wanted to find out where would be the best place to put in some of your Sojourner or the Opportunity tester when they land them on the planet up there. And one of the things that they selected was these outwash areas. Because out here you can get a collection of boulders that will be from the larger area of the planet. If you just went out into the basalt plateau area of Washington, if you didn't get any sediment from Washington or from Oregon, or not Oregon, but Montana, Idaho, and British Columbia, you wouldn't know as much. So one of the things they did, they brought a lot of their instrumentation and their mechanics over to the scabland to test it out. And they took a look at a lot of these large boulders, and it's amazing when you take a look at this, how much there's similarities between the two of them. They went into this is Sojourner in '97, looking at some of these rocks that were in these flood out areas on Mars. Well, one of the other things that Brett said, I think more than anything else, he gave us a true appreciation of the magnitude of these ice age floods. Of course, Pardee was the one for most of the Glacier Lake Missoula. All of it leaked together between those two individuals. We can see now how much of the landscape in the four-state area from here west has been involved in this flood story. It's quite large. I don't think there's any other geologic phenomena on this, or in the continental United States at least, that has the dimensions of this. Our park systems, they're small by comparison, and that's one of the reasons why we really think this particular feature and phenomena needs to be recognized by Congress. And he even compared the floods of the Ice Age period to the Grand Canyon in Colorado and said, you know, that really pales by comparison. And it's one's perspective perhaps, but it's very true, the magnitude and so forth of the two. And with that, I'll say thank you for coming this evening.